Part 2 of our lesson 2.7. We're covering 4 theorems in this section 2.7. We already talked about theorem 2.3, the right angle congruence theorem. In this video we're going to look at theorem 2.4, the congruent supplements theorem, and we're also going to look at theorem 2.5, the congruent complements theorem. We're going to focus on this one first. The congruent supplements theorem says this: if two angles are supplementary to the same angle, or congruent angles, then they are congruent. Here's a diagram, and this is the theorem restated using specific angles from this diagram. Angle 1 and angle 2 are supplementary, so that's two angles that are supplementary. And angle 3 and angle 2 are supplementary. Then angle 1 is congruent to angle 3. So we have these two angles, angle 1 and angle 3, that are supplementary to the same angle, angle 2. So our two angles would be angle 1 and angle 3, and they're supplementary to the same angle, angle 2. If you don't see it, I'll use some numbers for the measures to help. I'm going to say that angle 1 is 50 degrees. I know that angle 1 and angle 2 are supplementary, so that means that angle 2 must be 130 degrees. Angle 3 and angle 2 are also supplementary. So if angle 2 is 130 degrees, that means angle 3 is 50 degrees. Now notice what's happening here. Angle 1 and angle 3 are congruent angles, aren't they? They have the same measure. So this is what the congruent supplements theorem says. This is a shortcut. All theorems are shortcuts. So what's going to happen is we're going to end up using this a lot to prove other things. So you're going to have two angles that are supplementary, and then another two angles that are supplementary. That means these two angles are the same because that angle was in both of those supplementary statements. Okay? This is a theorem, so we need to prove it. And that's what we'll do next. So this is on your next slide, and we'll come back to this one afterwards. So we're going to prove a case of this congruent supplements theorem. And the reason we're proving a case of it is, in the theorem it says two angles are supplementary to the same angle or congruent angles. That's going to be a different case. So the case we're proving is that if two angles are supplementary to the same angle, then they're congruent to each other. Okay, so let's prove that two angles supplementary to the same angle are congruent. So here's our diagram again. Here's what you're given. Angle 1 and angle 2 are supplementary. Angle 3 and angle 2 are supplementary. Prove that angle 1 is congruent to angle 3. Now, we kind of walked through it on that last slide. You should believe it at this point. Okay, so that's always step one, is believe it. The next thing you do is you start proving it. So we're going to state our given. Angle 1 and angle 2 are sup. That just means supplementary. It's an abbreviation. Angle 3 and angle 2 are sup, or supplementary. That's given. Now, step 2, you're saying that these angles are supplementary. That's a term. What does supplementary mean? So notice how I'm going to define what supplementary means. Supplementary means the measures of the angles add up to 180. So if 1 and 2 are supplementary, measure of angle 1 plus measure of angle 2 equals 180. Also, measure of angle 3 plus the measure of angle 2 equals 180. They told you they're supplementary. You said what that means. They're supplementary. That's the definition. Now, at this point, you need to recognize that you have two different things, this thing and this thing. They both equal 180. So if you have two different things that equal the same thing, then those two things equal each other. So the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. That's your transitive property. Now, hopefully you can start seeing this thing shaping up to look like this. Notice how we have an angle 1 and an angle 3 on each side. Notice also that we have an angle 2 on each side. So if you have the same angle on each side, you could easily remove it from each side to say that the measure of angle 1 equals the measure of angle 3. All we did was we subtracted the measure of angle 2 from both sides. Now, if two angles have the same measure, doesn't that mean that those angles are congruent? That's your definition of congruence. Okay, so we just proved the congruent supplements theorem. So anytime you have two angles that are supplements of the same angle, you know they're going to be congruent angles. We don't need to throw these 5 steps into the next time we need this theorem in a proof. The next time we need this theorem right here in a proof, all we have to state is this is true by the congruent supplements theorem because we proved it this one time. So this is where this saves you time. These 5 steps will be condensed into one step the next time we need this in a proof. Okay? So that's the congruent supplements theorem. That's theorem 2.4. We also have a theorem 2.5. It's called the congruent complements theorem. And it says exactly the same thing as a congruent supplements theorem, except instead of supplementary, it's going to say complementary. So if two angles are complementary to the same angle, or to congruent angles, then they're congruent to each other. So we have some angles here. If angle 4 and 5 are complementary, I'm just going to make up a number now. Let's say angle 4 is 40. That means angle 5's got to be 50. They're complementary angles. Angle 6 and angle 5 are complementary. So if angle 5's 50, angle 6 needs to be 40. They're complementary. What do you notice about angle 4 and angle 6? They're complementary to, or not, they're not complementary to each other. That's what a lot of people end up saying. It's natural to say that. If two angles are complements of the same angle, then those two angles, they're not complementary to each other, they're equal to each other or congruent. Okay, so this is a theorem, and you need to prove that as well. Okay, so we have this slide here where you must prove this on your own. It looks exactly the same as the proof that we just did for the congruent supplements theorem, except you say complement instead of supplement, and you put 90 instead of 180.